Hi guys, so let's do some discussion of acids and bases. And let's just start with the basic properties of what is an acid and what is a base. So an acid is a substance that ionizes in aqueous solutions to form hydrogen ions, which we write as H+, and thereby it increases the concentration of protons in solution. On the other hand, a base is a substance that accepts or reacts with protons in aqueous solution, and therefore it produces hydroxide ions. So you'll notice here, remember, protons have a +1 charge and hydroxide ions have a -1 charge. So there are two different types of acids and bases. We can talk about someone named Arrhenius, or we can talk about the Bronsted-Lowry acid-base definition. So let's do Arrhenius first. So this is kind of a more old school definition, and it's limited because it only applies in aqueous solutions, which doesn't make it applicable to all situations. So an Arrhenius acid is a substance that, when dissolved in water, increases the concentration of protons in solution. Conversely, the base is a substance that, when dissolved in water, increases the concentration of hydroxide ions in solution. Okay, so remember that with Arrhenius, it only applies to aqueous solutions, and it deals with, for the acid, the increase in concentration of protons, and for the base, the increase in the concentration of hydroxide ions. So now let's move and talk about Bronsted-Lowry. It's a little more applicable to more situations. So a Bronsted-Lowry acid is a substance that can donate a proton to another substance. So we call that a proton donor. The base is a substance that can accept the proton, and so we call that a proton acceptor. So Bronsted-Lowry is applicable to a lot more real-world situations, and it's defined by whether or not the acid is the proton donor and the base is the proton acceptor. Similar to when we were talking about oxidation-reduction reactions, these things happen together. You have a proton donor, you must have a proton acceptor. So molecules of different acids can ionize to form different numbers of proton ions. Remember that when I say something ionizes, I'm saying that it breaks up into its respective plus and minus ionic species. So for example, we have here HCl and HNO3, so hydrochloric acid and nitric acid, two strong acids, very common. And you see they each have one proton. So we call those monoprotic acids, mono meaning one proton that can be donated to the solution. So these guys yield one proton per molecule of acid. On the other side, you could have a diprotic acid. So here it's sulfuric acid, which is H2SO4, which means it's got two protons to donate to solution. So diprotic acid, di for two, and it yields two protons per molecule of acid. You can go up and up. There's H3, PO4, various different types of acids. But just so you know here, these are the two most common that you'll probably come in contact with in your early chemistry days. And that's pretty much the basic properties of acids and bases.